Hello everyone, welcome to sjprogrammingsolutions. So in last video we have discussed about the lambda expressions and the functional interface. So in today's video we are going to see some more examples on the functional interface. Okay, now we already know what is the functional interface. So functional interface is an interface which contain only one abstract method and it may contain any number of default and static methods. Okay. If we want to make the functional interface explicitly, then we have one annotation @ functional interface. Okay. And what are the predefined functional interface we have? We have the runnable comparable. Okay. Now let's open the IntelliJ and see the example of the runnable interface. Okay. So here I already created the project and this is my functional interface demo class which contain the main method. Okay. Now we are going to see the example of the runnable interface. So here let's create one class. The name will be runnable implementation. Runnable implementation, and this class is implementing our runnable interface. Okay. Now if we go to the runnable interface, see this is the functional interface which contain only one method. So this is the run method which we have in this runnable interface. Okay. Now whenever we are implementing the runnable interface, we have to provide the implementation for the methods which are there in this runnable interface. So here we have this run method, so we have to provide the implementation for this. Okay. Now inside this run method, let's provide the implementation inside run method. Okay. So this way we have created this runnable implementation class which is implementing the runnable interface, and in this runnable interface we have the run method, so we have provided the implementation for the run method here. Okay. Now how we can access this run method? So here we have to write runnable is equal to new runnable implementation. Okay. So this is the implementation class. So we have created the object of this, and after that if we want to create the thread by using the runnable interface, so how we create the thread? Here we have to write thread is equal to new thread, and inside this thread we have to pass the runnable interface. Okay. So here we will pass this runnable. Okay. Now how to start the thread? So here we have to write thread.start method. Okay. So whenever we are writing thread.start, then our run method will get executed. Okay. So let's save this and run. So we will get the output inside run method. See here we are getting the output as inside run method. Okay. So this is the traditional way of creating the thread using this runnable interface. Okay. Now let's understand how we can convert the same with the lambda expression. Okay. So now let me comment this. So here we have to write the lambda expression. Okay. So very first let's write runnable, and to this runnable variable we are going to assign this lambda expression. Okay. So we already know the syntax of the lambda expression. So very first we have to send the parameters, then the lambda expression symbol, and after that we have to write the implementation and semicolon. Okay. So here let's write the lambda expression for this run. So copy this method and paste here. So here lambda expression doesn't have any name, so we can remove the name. It doesn't require this public void, so we can remove this. Run method doesn't have any parameters, so it will be empty, and after that here we have to give the lambda expression symbol. So this is the body of the lambda expression, and here we have to write the semicolon. Okay. So this way we have converted this to the lambda expression. Okay. Now this method have only one line of implementation, so even we can remove these curly brackets, so we don't need to write the curly brackets as well. Okay. So after that what we have to write? We have to call the thread dot this one thread dot start method, right? So here first create the object of the thread is equal to new thread, and here we have to pass the runnable, and then by using this thread we can call this start method. Okay, now if we execute this is our lambda expression. Here we have created the thread and here we have started the thread. Now if I execute this, we are getting the same output which is inside run method. See here. Okay, now how again we can make some changes here. So see, lambda expression we can assign to some variable. Also we can pass the lambda expression to the method as a argument. Okay, so here we are passing the runnable. So instead of this, if we copy the lambda expression, okay, and just paste here, then we can remove the first line as well. Okay, after that, why we have created this thread here? Because here we are writing thread dot start. Okay, now we can remove this thread. Okay, and here itself we can call the start method. See, and then we can remove this line as well. Okay, so now if you can see how many lines of code we have written here, only one line of code. Okay, before the lambda expression, how we were doing the things, we were creating this runnable implementation class which is implementing the runnable interface. Here we are providing the implementation for the run method, and then here we are creating the object. Then by using this thread dot start we are starting the thread. This many lines of code we have to write, right? But if we are using the lambda expression, then our task is done only within one line. Okay, so that is the difference. If I remove this, okay, and even we don't require this class, so we can remove this, save, okay, and run this. See, you will get the same inside run method as a output. Okay, so I hope you understood how, like, this example of the runnable interface with the lambda expression. Okay, now let's go to the slide. Okay, now we understood like what is the functional interface and how we create the functional interface. Also we have seen the example of the runnable interface. Okay, now we are going to see some types of functional interfaces. Okay, so we have function, consumer, predicate and supplier. So we are going to see what is these interfaces and what are the methods they have and how we can make use of them. Okay, so let's start with the function. So this function is also a functional interface which contain one abstract method which is this apply. Okay, now if we talk about the function, so this function interface is available inside the java.util.function package, and this function interface accepts one argument and produce a result. Okay, so if you see this apply method is taking one argument as a t. T means what is the type of the input, whatever input you are providing, what is the type of that input. Okay, for example, if you are sending the input as a string, then here the type will be string. If you are sending the input as an integer, then here the type will be integer, that way. And what it is returning the result. Okay, so R means what is the type of the result. For example, if you are sending the input as a string and you want to return the length of the string, so length means that is of type integer, right? So here the R will be your integer type. So T means the type of the input and R means the type of the result or the output. Okay, so after that, when we use this function interface, means in the Java 8 we have the stream API. In the stream API there is one method map. Inside that method mostly we use the function interface. Okay, so whenever we will discuss about the stream, that time we will see like how we are using this function in the map method. Okay, now let's go to the IntelliJ and see the example of this function interface. Okay, so let me open the IntelliJ, and here in my project let me create one class. Let's give the name as a function demo. Okay, now this is our function demo class, and here let's create the main method. Okay, now here let me create one class and we'll give the name as a function implementation, and this is implementing the function interface. Okay, so we already know function interface is means if we like go into this function interface, let me show you. Here we have T and R. Okay, this is the generic one. T means what is the type of your input, R means what is the type of your output. Okay, and in this interface, see here, this is the functional interface and this contain one apply method. Okay, this apply method is also taking T. If you see here, T means what is the type of your input, R means what is the type of your result. Here they have mentioned everything. Okay, now go to the function demo class, and here let's take the type as a input type as a string and output as a integer. Okay, now here we have to provide the implementation for the apply method. So in this function interface we have this apply method. Okay, so see here it is taking string as a input and output is integer. Okay, so now what I want to do, I want to send the input as a string and return the length of the string. So here we can write yes dot length. Okay, so now we will get the length of the sent string. So let's go to this function demo, and here how we can create the, how we can access this method. So function, it is taking string and integer. Okay, then function is equal to new function implementation. Okay, and then by using this function we can call the apply method, and here we have to pass the parameter. So we are passing the string as a parameter. So let's pass here as programming, and in output we will get the length of the string. So here we have programming, so we will get the length of this programming string. We want to see the output, so let's write this inside our sysout. Okay, so save, and now if I run this, I will get the length of programming string. Okay, so see here the length is 11. Okay, so this is the traditional way of the function interface. Okay, now let's convert the same to our lambda expression. Okay, so how we can convert it? So here let's copy this apply. Okay, and here instead of this, or first let's remove this. Okay, so here we will create the function string integer, and let's give the name as a function, and here we want to create the lambda expression for this method. Okay, so now we already know this lambda expression doesn't have the name, even it doesn't require the return type and this public access modifier. So remove everything. Now it is taking one parameter. Okay, so let's keep that parameter. After that we have to use the lambda expression symbol. This will be our body. After the body we have to give the semicolon. Okay, now here we are returning the length of the string. In the lambda expression we don't have to mention the return. Okay, automatically it will get to no. Then this is the one line implementation, so even these curly brackets are not necessary. We can remove these curly brackets. Okay, now see here, as a parameter we are passing string as a input. So in the lambda expression, this type or the data type also not required to send, so we can remove it. See here, now our lambda expression is ready. Okay, so this is taking string as a input and returning the length of the string. Okay, now let's write one system.out.println, and here we will call the method function.apply, and here let's write now hello. Okay, and now we can remove this. See here, only within the 2 lines our task is done. Okay, so run this and we will get the length of the hello. So see here, the length is hello. Okay, so this way we can create the function interface. Okay, see here, so this is the functional interface which take this T means type of the input, R means type of the output, and it is having this apply as a abstract method. It takes the input and returns the output. Okay, after that we have one more method which is the compose. So this is the default method of this function interface. Okay, and if we go up below, this is and then, this is also the default method. And one more method we have which is identity. So this is the static method. So in function interface we have 4 methods, one abstract method, 2 default methods and one static method. Okay, so I hope this is making sense to you. Okay, so if we go to our presentation, so here this is the example. Okay, this example I have created for return means taking the input as an integer and returning the square of that integer. Means if we are passing here 8, it will return 8 into 8. Okay, so just see here how many lines of code we have written without lambda expression and how many lines of code we have written with lambda expression. So that is the difference. Okay, so that's it about the function interface. Now let's discuss about the consumer. Okay, so consumer interface takes the single input arguments and returns no result. It have one method which is the accept. Okay, so this accept method is taking the input but not returning anything. Okay, so consumer means what? It will consume the input but will not return anything. Okay, so let's go to our IntelliJ and let's see the example of the consumer interface. So let's create one class here, new class, and give the name as a consumer demo. Okay, and in this consumer demo let's have one main method, and then here let's create one class consumer implementation, and this will implement the consumer interface. And see here, consumer interface is coming from java.util.function and it is taking only the type of the input. Okay, so here let's give the input as a string. Okay, now if we go to the consumer, see here, this consumer is also a functional interface and it is having this accept as a input, accept as a method. Okay, and if we go below, we have one more default method which is and then. Okay, now if we talk about this accept method, see here, it will take the input. Okay, but what it is returning? It is returning the void. Okay, now let's go here and provide the implementation. So implement methods, provide the implementation for this accept. Okay, now it is accepting the string as an input. Okay, now let's do some operation like print the yes dot to uppercase. Okay, and here how we can access now or call this method, we have to write consumer, it is taking string as a input, and let's give it as consumer is equal to new consumer implementation, and then consumer dot accept method. Okay, so it will take the input, let's give as hello. Okay, so it will take the input, and here we are printing the same string in the uppercase. So save and run. See here, we will get the hello in the uppercase. See here, this is the output. Okay, now here let's convert this to the lambda expression. Okay, so how we can convert this into the lambda expression? So here let's remove this, and here we are going to write the lambda expression for this accept. Okay, how to write the lambda expression? Very basic thing. This is the input parameter, then lambda expression, and this is the body of your lambda expression. Here we have to give the semicolon. Okay, now see here, this accept is taking one input which is of type string. Okay, so we can give here the parameter. Okay, even we don't require to write the type, so we can remove this, and here what implementation we have, we are just printing the same string in the uppercase. Okay, so we can remove this curly brackets, and in one line our task is done. So here let's call now consumer dot accept, and here we will give hello, or let's take world. We can remove this implementation class, and now if we run, we will get the output as a run. Okay, we will get the output this world in the uppercase. So see here. Okay, so this way we can implement the accept method by using the lambda expression. Okay, now let's go to the slide. So this is the consumer method. Okay, this consumer method will take the single input and returns no result. Okay, and here we have one abstract method which is accept. Okay, so mostly this consumer we use in the collect, for each. Okay, in maybe in coming video, whenever we will discuss about these things, that time we will take the examples as well. Okay, now here this is the example. Okay, without lambda expression we already seen, like here we are taking string as a input, and just here we will print the same string in the uppercase. Okay, and this is the code with lambda expression. We need 2 lines here, and here see how many lines of code we are returning. Okay, so I hope you understood how we can use the consumer interface. Okay, now let's go to the next one, which is the predicate. Okay, now what is the predicate? Predicate is also a functional interface. Okay, and it will take a boolean valued function of an argument, means this predicate will take one argument. Okay, so t means type of the input. Okay, so if you see here, this predicate is having one method which is test. This test method is taking the input and returning the boolean value. Okay, it will take one argument and return the boolean as a result. Okay, so mainly where we use this predicate, we use the predicate in the filter. Okay, whenever we are filtering, that time we use the predicate. Filter is the method which is available in the stream. Okay, so in coming video we are going to discuss about the stream, filter, map. So that time we are going to discuss these things as well in detail. Now filter means what? Let's I will give you in very easy way. Like filter means, let's suppose you have the list of integers, and you want to filter that list of integers like based on some like you just want to filter the even number, you just want to filter the odd numbers. Okay, that time you can use the filter. Okay, and now when you want to check that the number is even or, that time you can give you can write some logic, and that will return, if that is the even number it will return true, if that is the odd number it will return false, right? So that way we can use make of this test method from this predicate in our filter. So we will see with the examples, don't worry about that. Okay, now the predicate has a test method which accepts an argument and returns a boolean value. Okay, now see, this is the example of the predicate. Okay, see here what we did, we have created this predicate implementation class. This is implementing the predicate interface. Okay, this predicate interface is taking the string, okay, as a input. Now in this predicate we have one method test, so we have provided the implementation of the test. So here we are passing string as an input, and we want to check that is that string length is greater than 5. Okay, so that's why here I have written s dot length greater than 5. Then in our main method we have created this predicate, and then we are calling the test method, and in the test we are passing this string as a input. Okay, so this is the traditional way, this is the lambda expression way. So now let's go to the IntelliJ and do the same. Here let's create one more class, and we will give the name as a predicate implementation, and no, actually let's give the name as refactor it to the demo. So this will be having the main method, and here we have to create one more implementation class for the predicate. Okay, so predicate implementation, and this will implement the predicate interface. Okay, and here we are going to pass string as a input. Okay, now if we go here in the predicate, you will see this is the functional interface, and which is having this test method. So this is taking one input and returning the boolean as a result. Okay, now if we come here, here we have one more method. This is the default method. Okay, and this is also a default method, and this is equal is a static method, then not is the static method. Okay, so two static method, and I think two default method we have, and one abstract method is available in the predicate. Okay, let's go to the predicate demo, and here we have to implement the test method. Okay, now here what we want to test is the sent string. In the argument we are getting the string, the length of that string is greater than 5 or not. If it is greater than 5, it will return true, otherwise false. Okay, so let's save this, and here let's create the object of this predicate, and string predicate is equal to new predicate implementation, and here we have to call the test method. So here let's pass the string as hello world. So see here, now this length of this string is greater than 5, right? So it will return the result as a true. Save and run this. So you will get the result as a true. Okay, so here actually we have to write this inside our sysout statement. Now save and run, you will get the output. See here, true. Now if I pass here just he, and if we run now, it will give the result as a false. See here, false. Okay, so this way we can use the test method of this predicate functional interface. Okay, now let's convert this into the lambda expression. Okay, so how we can create the lambda expression? You can copy this, remove this and paste here. In the lambda expression, we don't need the name of the method, so remove the name, void, public, everything. After that, we have to give the lambda expression symbol, and after the body we can give the semicolon. Okay, so here the return is also not required, and this is only the one line implementation, so we can remove this curly brackets. Okay, and this one as well. Okay, now you can remove this class and see here your lambda expression is ready, which is taking the string as an input and returning the, like, it is checking that if the length of the string is greater than 5, then it will return true, otherwise it will return false. Okay, so in this case it will return false because here we have only the length as a 2. So let's run this and see. We will get the result as a false here. Okay, we have to write it in the system.out.println, run. Now you will get the result. See here, false. Okay, so this is the example of the predicate. Now I think one more is remaining. Okay, so this is the example of predicate. Now one more is remaining, which is supplier. Okay, so supplier is also a functional interface. Okay, in this supplier interface we have one method which is get, and this get method will not take any number of argument. Means this get is the method without any argument, but it will produce a result. Okay, so see here, it represents a function which does not take in any argument but produces a value of type t. Suppliers are useful when we don't need to supply any value and obtain a result at the same time. Means if we don't want to send the argument but we want the result, then we can use this supplier interface which contain this get method. Okay, this get does not take any argument but produces a value of type t. Let's go to the IntelliJ and see the example of the supplier. Okay, so here let's create the class and give the name as a supplier demo. This supplier demo will have the main method. Okay, and here let's create one more class, supplier implementation, and this will implement the supplier interface. Okay, now this supplier interface, let's see, it is returning the double. Okay, we will give it as a double, and if you go to the supplier, see here, this is the functional interface and this is having one method get, which doesn't take any argument but it will return a result. Okay, now go to your supplier demo class and provide the implementation for the get method. And now here what I want to return, I want to return the random number every time. Okay, so go to the main method and here you can write supplier of type double and random number is equal to new supplier implementation and random dot get. Okay, actually I have to write this in the system.out.println so that we can get the result. So if we run this now, we will get the randomly generated number. See here. Okay, so this way we can write the get method of this supplier interface. Okay, Now let's convert this to the lambda expression. So we don't require all these things. So let's remove it. And here what we have to write, the lambda expression. So what is the syntax of the lambda expression? It will take the input, then lambda expression symbol, and then this is the body, and after that we have to write the semicolon symbol. So here the get method is not taking any input, so it will be empty. Then lambda expression, here we want to return the random number. So how we can write? Math dot random. That's it. Okay, so this is the lambda expression implementation of your get method of the supplier interface. Now if you run this, you will get the randomly generated number. See here. Okay, so this is the example of the supplier. So if we go, see here, this is the example, same example which we have did. Okay, this is without lambda, this is with lambda. Okay, so what are the things we have discussed in today's video? We have discussed about the functional interface. Then we have seen the example of the runnable interface, and then after that we have discussed about this 4 types of functional interfaces: function, consumer, predicate and supplier. Okay, so I hope you have understood everything. If you have any questions, you can mention in the comment section, and in the next video we will see this one, why we cannot have multiple abstract methods inside the functional interface. Okay, with the practical implementation we are going to discuss on this question in the next video. So thank you for watching the video. If you find it useful anyway, please share with your friends and don't forget to subscribe the channel. Thank you.